Good day, everyone, especially to our instructor, Engineer Churchill Ismael, and to my fellow civil engineering students. I am Jamel Joy M. Villanueva from BSCE 4A. This time, we will talk about falling head permeability. To start with, I will briefly discuss the definition of permeability. The property of the soil, which permits the water or any liquid to flow through its voids, is called permeability. Permeability is the ease with which water can flow through the soils. Let us now proceed to falling head permeability. The falling head permeability test is a common laboratory testing method used to determine the permeability of fine-grained soils with intermediate and low permeability such as silts and clays. This testing method can be applied to an undisturbed sample. The falling head permeability test involves flow of water through a relatively short soil sample connected to a standpipe, which involves the water head and also allows measuring the volume of water passing through the sample. The diameter of the standpipe depends on the permeability of the tested soil. The test can be carried out in a falling head permeability cell or in an odometer cell. So this is the falling head permeability test setup. Consisted of a standpipe, filter disc, soil sample, constant exit head, and a datum. Before starting the flow measurements, the soil sample is saturated and the standpipes are filled with the aired water to a given level. The test then starts by allowing water to flow through the sample until the water in the standpipe reaches a given lower limit. The time required for the water in the standpipe to drop from the upper to the lower level is recorded. Often, the standpipe is refilled and the test is repeated for a couple of times. The recorded time should be the same for each test within an allowable variation of 10%, otherwise the test is failed. On the basis of the test results, the permeability of the sample can be calculated as K is equals to A times L divided by A quantity T sub 2 minus T sub 1 close quantity, Ln quantity H sub 1 divided by H sub 2 close quantity, in which we have L, the height of the soil sample column, uppercase A, the sample cross-section, lowercase a, the cross-section of the standpipe, delta T, the recorded time for the water column to flow through the sample, H sub 1 and H sub 2, the upper and lower water level in the standpipe measured using the same water head reference. Let us have sample problem number 1. A falling head permeability test was run on a soil sample 9.6 centimeters in diameter and 10 centimeters long. The head at the start of the test was 90 centimeters. The coefficient of permeability of the soil was found to be 5 times 10 raised to negative 6 centimeters per second. The diameter of the standpipe was 1 centimeter. A. Determine the flow at the start of the test in cubic centimeter per hour. B. Determine how much head was lost during the first 30 minutes. C. Determine the flow after 30 minutes in cubic centimeter per hour. Now, let's look at the figure from the sample problem number 1. Solution for part A. Since it is already given that 90 centimeters is the height of the water, then the equation Q is equals to KIA came from the Darcy's law, which Q stands for the discharge, K is the hydraulic conductivity, I is the hydraulic gradient, and A is the cross-sectional area through which flow occurs. Now, by direct substitution to the given formula, we yield Q is equals to 0.003257 cubic centimeter per second, or convert to 11.72 cubic centimeter per hour, and that would be the final answer. Now for part B. Determine how much head was lost during the first 30 minutes. And again, we use this formula from the previous solution. Now in the equation, from the area of the standpipe, pi over 4 times 1 squared times length, which is 10, divided by pi over 4 times 9.6, which is the area of the soil, squared, times time, 1,800, which is the converted 30 minutes, 2 seconds, times ln, quantity 90, divided by h sub 2, closed quantity, is equals to 5 times 10 raised to negative 6. Solving the equation by simply using algebra. And in order to have a simplified equation, just like this. So we already got the value of h sub 2, which is 82.84 centimeters. Now we subtract h sub 2 to h sub 1, which is 90. Then the loss of head is equals to 7.16 centimeters. And that will be our final answer for part B. Now for part C, determine the flow after 30 minutes of the test in cubic centimeter per hour. Once again, let us use the Darcy's law equation, Q is equals to KIA. By substitution of the given to the formula, 5 times 10 raised to negative 6, quantity 82.84 divided by 10, closed quantity, pi divided by 4 times 9.6 squared. Q is equals to 0.002998 cubic centimeters per second. Or let us convert it to cubic centimeter per hour. Then, it will be equal to 10.79 cubic centimeter per hour, and that will be the final answer for part C. Moving on to sample problem number 2. For a falling head permeability test, the following data were recorded. Length of soil specimen, 500 mm. Area of soil specimen, 16 cm squared. Area of standpipe, 0.97 cm squared. Head difference at time t is equals to 760 mm. Head difference at time t is equals to 6 minutes, 410 mm. The test was conducted at a temperature of 20 degrees Celsius with a unit weight of water equal to 9.789 kilonewton per meter cube, and the viscosity of water at 20 degrees Celsius is 1.005 times 10 raised to negative 3 Newton second per meter squared. A. Compute the hydraulic conductivity of the soil. B. What is the head difference at time t is equals to 4 minutes? So here is the figure for the sample problem number 2. To solve for part A, we have to use again the formula. And by direct substitution of the given to the formula, we have 0.97 times 50 divided by 16 times 6, which is the 6 minutes, ln times 760 divided by 410 is equals to 0.31 centimeter per minute, which is the final answer. For part B, again, using the same formula but different time. Also, the value of K is already given, which is 0.31 from the previous solution. And by direct substitution and using algebra, we can simply get the value of H sub 2. And the value is 504.84 millimeters. Final answer. Conclusion. The falling head permeability test has a high dispersion and is not sensitive to changes in porosity. The constant head permeability test is a viable and economical alternative to measure the permeability of the material. And lastly, constant head method is suitable for large-grained soils which are relatively more previous because of their larger voids, while variable head is more suitable for small-grained soils which are relatively less previous because of their poorly connected void structure. And here ends my presentation. Thank you and God bless, and I hope you have learned something from me today.